This is a revision video for P5C projectiles. When you kick a football, it takes a curved path through the air. The path of the football has this curved shape because of the Earth's gravity. Anything that is thrown or projected through the air has a curved path, and this is called a projectile. Other examples of projectiles are missiles and cannonballs, and all balls that are hit, thrown or kicked in sports. A dart is a projectile when it has been thrown, and long jumpers are projectiles from the moment when their feet leave the ground. The curved path of a projectile is called its trajectory. The shape of the path of a projectile is said to be parabolic. After a projectile has been thrown or kicked, the only force acting on it is gravity, apart from air resistance. But for our calculations, we need to neglect air resistance. Velocity is a vector quantity. It's got both a size and a magnitude. And you can separate out the velocity of the ball into its horizontal and its vertical components of velocity. If we look at the diagram, these snapshots of the ball have been taken at the same regular time interval. If we consider the horizontal velocity, you can see that the distance between each of those balls after the given time interval is the same. That means that because distance is the same and time is the same, it means the velocity is the same. So horizontally, the object has a constant horizontal velocity. If you consider the vertical component of velocity, you can see that the time intervals, although they are the same, they get further apart as we go down the cliff. This is because that gravity is acting upon the ball and its acceleration is constant, which means it's getting faster as it falls, so its velocity is increasing. So key things to remember are that the horizontal velocity is constant, that's if you are ignoring air resistance, and the vertical velocity increases as you get further down the cliff. How far a ball travels when it's hit, or its range, depends on the angle at which it leaves the ground. This is called the launch angle. If the launch angle is high, the ball will not travel as far because the horizontal velocity will be smaller. So if we launch our projectile with a very high angle, then its range will be the distance it has travelled, the horizontal distance it has travelled. If the launch angle is low, the ball will fall back to the ground in less time. So if we draw on our ground and we have a very low launch angle, the ball won't travel very far either. The optimum angle, or the greatest range, is achieved when the angle is 45 degrees. So if you want your projectile to go as far as it possibly can, it needs a launch angle of 45 degrees. The horizontal and vertical velocities of a projectile are vectors. The resultant velocity of a projectile is the resultant vector of these horizontal and vertical components. You can use the equations of motion from a last video to work out how long it will take for a projectile to hit the ground and to work out how far it has travelled. You use the equations separately for the horizontal and the vertical parts of the motion. So you must split up the horizontal component and the vertical component. Okay, so here's an example. A football is kicked from the edge of a cliff with a horizontal velocity of 15 meters per second. It takes 4 seconds to land in the sea. What is the height of the cliff? What is the ball's horizontal velocity when it lands in the sea? What is the ball's vertical velocity when it lands in the sea? And what is the range of the ball? I want you to stop the video and see if you can remember how to do this question. Remember, you need to split up the horizontal and the vertical components, and as always, write down what you know before you pick an equation to use. Okay, so what is the height of the cliff? You know that this is a vertical height. However, I would still start these questions writing down what you know both horizontally and vertically. So it told us that the horizontal velocity was 15 meters per second. That means that at the point when the ball is kicked, it only has that horizontal velocity. And it doesn't have a velocity going vertically. So U for vertical is 0. Okay, then we also know that horizontally the ball is not accelerating, or it's staying at a constant velocity. So our acceleration is 0. We know that gravity is acting on the ball because we are on Earth, and gravity on Earth is 10 meters per second squared. We know that time is 4 seconds, so the ball takes 4 seconds to reach the water. So that's the same, both horizontally and vertically. And then other than that, we don't have any more information. So we don't know the range, the distance from the bottom of the cliff. We don't know the height of the cliff. And we don't know the final vertical velocity. However, this question is asking us for the height of the cliff. So we're looking at our vertical section here. We have U, we have A, we have T, and we want S. So the best equation for us to use is S equals UT plus half AT squared. Now if we put our numbers into that equation, it comes out with a vertical height of 80 meters. Okay, so the next bit of the question. What is the ball's horizontal velocity when it lands in the sea? Well, we know the fact that horizontally the velocity does not change. So the velocity is the same as the initial velocity, which is 15 meters per second. If we're looking, however, at the ball's vertical velocity, we know that this does change because gravity is acting on the ball. We know that our U is 0, we know that acceleration is 10, and we know that the time taken is 4. So we could use V equals U plus AT. We put our numbers in there. The ball's vertical velocity is 40 meters per second. Okay, and the last one, when we are talking about the range of the ball, or the distance the ball has gone from the bottom of the cliff, we are only using the horizontal velocity, or the horizontal components. We want S, which is going to be the distance from the bottom of the cliff. We have U, which is 15. We also have V, which is 15. Because as the ball is travelling, its velocity does not change horizontally. And then we've also got the time, which is 4. So if we put those into the equation, S equals half U plus V times T, then we can see that the range of the ball is 60 meters, or the ball has travelled 60 meters from the bottom of the cliff when it hits the water. Okay, so it's time for you to have a go at one of these questions. What you should do first is draw yourself a diagram so you know what's going on. It helps you to visualise the information in the question better. Then you need to split it up into horizontal and vertical components. Then you need to write down what you know in each section. So what you know in the vertical section and what you know in the horizontal section. When you've done that, you can then start working out which equations that you are going to be required to use. Okay, so here is the solution. We've got a stunt car drives off horizontally a small cliff with a velocity of 12 meters per second. The cliff is 1.25 meters high. 1. How long does the car take to hit the ground? And 2. How far from the base of the cliff will the car land? Now for number 1, we can find this value through looking at the vertical part of the motion. We know that the height is 1.25 meters. The initial vertical velocity is 0 because the car is travelling horizontally when it leaves the cliff. And the vertical acceleration is 10. Okay, and we are wanting time. So we have T, S, U and A. So the best equation for us to use will be S equals UT plus half AT squared. Now if we put our numbers in there and do a bit of rearranging, we get that T is 0.5 seconds. In order to work out the range of the car, or how far from the base of the cliff the car will land, we need to look at the horizontal part of motion. Now we were told that the car leaves the cliff with a velocity of 12 meters per second. This is the horizontal velocity. It stays the same, remember? Horizontal velocity does not change. And we also know that the car lands 0.5 seconds after it left the cliff. We just worked that out in the calculation here. Okay, now because the horizontal velocity is constant, then we can do distance equals velocity times time. The horizontal velocity is 12 and the time is 0.5, which gives us a distance of 6 meters. So the range of the car is 6 meters from the bottom of the cliff. Okay, that brings an end to this revision section on projectiles. I want you to stop the video now and have a go at some of these graded questions. Remember to always draw your diagram first, then split it up into horizontal and vertical components and write down what you know. Then you can choose an equation to use.